Hello everyone. So in this video, I'm going to talk about another hemolytic disease, acquired autoimmune hemolytic diseases. Okay, which are also called AISD in short. Okay, acquired autoimmune hemolytic disease. So before talking about this one, I want to recap something from the previous lecture. Okay, so in the previous video lecture, I talked about the hemolytic disease of newborn and infant, erythroblastosis fetalis. Right. So basically, we know that the hemolytic disease of newborns are mainly occurs because of the difference in the RH. Okay, R is positive or negative. If there is a difference between the fetus and the mother, okay, R is positive, negative. But is RH is the only thing that differs between the fetus and mothers? No. How about the ABO? Okay, ABO also differs, right? And I think different ABO, they also have different antibody or antigen. Suppose group A, they have B antibody and A antigen. Group B, they have anti-A antibody and B antigen. Then if a group A mother have a fetus of group B, then why don't reaction occurs? Okay, so which are called ABO hemolytic disease. I mean, if disease occurs by the ABO difference in the ABO, this is called ABO hemolytic disease. Okay, but usually the ABO hemolytic disease of newborn, they are mild to minimal. Why? Basically, there are three reasons. Number one, anti-A or anti-B antibodies are usually IgM and therefore do not cross the placenta. Okay, listen carefully. IgM. So suppose the mother is group A and the fetus is group B. Okay, so fetus has B antigen and mother has B antibody. So this antibody can interact with the B antigen and sensitize it and cause the hemolysis, right? But this cannot occur because these antibodies, anti-B, anti-A, which are already in the mother's body, they are basically IgM antibody, and IgM are big in size. So they are bigger, so that's why actually they cannot cross the placenta and cause the disease. Okay. And another reason is ABO blood group antigen are very widely distributed in the fetal tissue and placenta. I mean, the placenta get blood from the mother, so they are widely distributed there. Okay, and another third cause is ABO blood group erythrocytes are not fully expressed on fetal erythrocyte. Usually, fetal erythrocyte, you can say they're kind of immature in comparison with the adult erythrocytes. So that's why in the fetal erythrocytes, this AB, the antigens, they are not fully expressed. Okay. So as those antigens are not fully expressed, that's why actually there is very less chance that these antigens will interact with the antibody present in the mother's body. Okay. So okay, let's move back to the AISD, acquired autoimmune hemolytic disease. Okay, so this occurs, I mean, you already know when autoimmune hemolytic disease occurs when the patient develops antibody against its own erythrocytes. Okay, and how we can treat this condition? Basically, there is two ways: either by through intravenous infusion, and another is long-term immunoglobulin treatment. Okay, so in case of intravenous infusion, so intravenous infusion of immunoglobulin can protect the acute hemolytic phase by blocking macrophage FC receptors. Okay, basically intravenously we have to inject immunoglobulin. Okay, that is antibodies. And in case of long-term immunoglobulin treatment, it can prevent additional hemolytic attack. Okay. Anyway, the AISD disease, they can be like two types. One is warm antibody disease, another is cold antibody disease. Okay, they are named this because the one antibody disease which occurs in high temperature, the cold antibody disease it occurs in lower temperature. Okay, so in the next slide, I'll talk about this warm and cold disease. However, not in very details. Okay, just we'll try to get a overall idea. Okay, so first, warm antibody disease. So in this case, the patient's erythrocytes is destroyed by action of IgG antibody. Okay, immunoglobulin G antibody and the complement. Okay, the main cause of the appearance of this warm antibody is unknown. Okay. However, the antibody production is associated, and this is known that the antibody production of warm antibody is associated with a collagen disease, SLE, or lymphoproliferative disorder, leukemia. I mean, in this case, the warm antibody can be produced, but the exact mechanism or causes are not known. Okay, and the treatment for warm antibody disease is one, corticosteroid. Okay, steroid, corticosteroid or steroid. So what does this do? Steroid or corticosteroid, they decrease the affinity of FC receptor binding. FC receptor binding. Okay, and decrease phagocytic activity and decrease antibody production. Okay, so by this, doing this, the steroid can treat the warm antibody disease. Okay, so how about the cold antibody disease? Cold antibody disease are caused by IgM or IgG. Warm antibody disease was caused by IgG, okay, but the cold one IgG or IgM, okay, and this disease, that is cold antibody disease, is associated with some viral infection or lymphoproliferative disease. Okay, so I mean, if the person has lymphoproliferative disease or have some viral infection, then that person or patient can develop cold antibody, right? Which can eventually cause the cold antibody hemolytic disease. Okay, so what happens in this case? The erythrocytes, they get coated by IgM at around at less than 37 degrees Celsius. Okay, they get coated, and at 37 degrees Celsius, this antibody coated erythrocytes, they bind with the complement, and once the complement bind, eventually the cells get lysed. Okay. And the cold antibody hemolytic disease, they occur in two forms. One is paroxysmal cold hemoglobinuria, and another is cold agglutinated disease. Okay. So now first, the paroxysmal cold hemoglobinuria. Okay. This disease is caused by immunoglobulin G, and the specificity is usually to blood group B. Blood group B is another blood group, okay, like the ABO blood group, okay. And this disease, that is the paroxysmal cold hemoglobinuria, is associated with syphilis or viral infections. Okay, so how it can be diagnosed? The diagnosis can be done by checking the urine. So dark urine, because of hemoglobin which get lysed. Okay, so diagnosis can be done in vitro. How? Patient's serum mixed with erythrocytes at 4 degrees Celsius, and the mixture is warm to 37 degrees Celsius, cells lysed. Okay, I mean, how you can check? Collect the patient's serum, okay, and mix this patient's serum with erythrocytes. I mean, in the laboratory, you can do it in the petri dish or a slide. Okay, mix the patient's serum with the erythrocytes, but you have to mix it at cold temperature at 4 degrees Celsius. Then you have to warm them up to at around 37 degrees Celsius. And if the reaction occurs, then it will cause the lysis of the cells. Okay, so this is the diagnosis procedure of paroxysmal cold hemoglobinuria, and the treatment is usually this disease is self-limiting. I mean, within 2 to 3 weeks the patient get cured. And another is, the persons who has this kind of disease, the paroxysmal cold hemoglobinuria disease, they should avoid the cold temperature. If they can avoid cold temperature, then they can avoid this disease. Okay. And the another, there was two types of cold antibody disease. So I already talked about the paroxysmal cold hemoglobinuria. Now the cold agglutinated disease. Okay, cold agglutinin disease. So in this disease, agglutination of red blood cells occurs in cold. Again, it's a cold antibody disease. So, and caused by monoclonal and polyclonal antibody, and directed to the blood group I. Blood group I, another blood group. The paroxysmal one was against blood group E, and this one called agglutinin is directed to blood group I. Okay. However, mycoplasma infections can also cause this disease, and it caused by polyclonal antibody formation. Okay, and lymphoproliferative disease. In case of lymphoproliferative disease, cold agglutinin is caused by monoclonal antibody. Okay, so in the second line, I mean, it is written that this cold agglutinin disease can caused by both monoclonal and polyclonal antibody. Okay, so the monoclonal occurs in case of lymphoproliferative disease, and the polyclonal occur in case of mycoplasma disease. Okay, so that's all for this video. In the next video, we'll talk about a different type of cytolytic reactions which is caused by drug. Okay, so far we talked about the cytolytic reactions which is caused because of the blood group system. Okay, but in the next video we'll talk about another type of cytolytic reaction which is caused due to drug. Okay, see you then. Bye.